Mount Etna spews ash, again in June 2026, as scientists monitor growing fears of a potential catastrophic flank collapse. Sicily, Italy, Europe's most active volcano, is once again showing signs of unrest. Throughout June 2026, renewed ash emissions and persistent volcanic activity at Mount Etna have captured the attention of volcanologists across Europe. While the latest eruptions are relatively moderate compared to some of Etna's historic paroxysms, scientists are increasingly focused on a much larger concern hidden beneath the volcano's massive eastern flank. The immediate threat comes from continuing ash emissions, small explosive events, and ongoing magma movement beneath the volcano. Reports from monitoring networks indicate that summit craters have continued releasing ash plumes during June, following several eruptive episodes earlier in 2026. In March, an explosive event at the Bocca Nuova crater generated a significant ash emission following a local earthquake swarm, highlighting that magma remains active within the volcanic system. Mount Etna has been particularly active over the past 2 years. A major eruptive phase began on the 1st of January 2026, when lava emerged from fissures on the volcano's eastern slopes within the Valle del Bove region. While the eruption did not threaten nearby communities, it confirmed that magma continues to migrate through Etna's complex plumbing system. But beneath the spectacular displays of lava and ash lies a deeper geological mystery. For decades, researchers have known that Etna is slowly moving toward the Ionian Sea. High-precision measurements reveal that portions of the volcano's southeastern flank are gradually sliding seaward. While the movement is measured in millimeters each year, geological studies suggest the process has been occurring for thousands of years. The possibility that concerns scientists is not an imminent eruption, but the potential for a large-scale gravitational collapse of part of the volcano's flank. Such collapses have occurred in volcanic regions throughout Earth's history and can generate massive landslides and destructive tsunamis. Evidence suggests that a major collapse occurred on Etna thousands of years ago, creating the enormous Valle del Bove depression visible today. Some researchers believe that event may have triggered a significant tsunami across parts of the eastern Mediterranean. Modern monitoring systems have detected ongoing deformation both above and below sea level. Instruments positioned on the seafloor have confirmed that portions of Etna's underwater flank continue to shift independently of volcanic eruptions, suggesting that gravity itself plays a major role in the volcano's movement. Scientists emphasize that there is currently no evidence that a catastrophic collapse is imminent. However, continued eruptive activity, earthquakes, and magma intrusion can all influence the stability of volcanic slopes. The combination of volcanic pressure and long-term gravitational movement makes Etna one of the most closely watched volcanoes on Earth. Recent history demonstrates how quickly Etna's behavior can change. During the dramatic June 2025 eruption, a collapse within the volcano's southeast crater generated a powerful ash cloud and pyroclastic flow that sent tourists scrambling from the slopes. Although no injuries were reported and authorities declared the event largely harmless, it illustrated the volcano's ability to produce sudden and dramatic changes with little warning. Today, an extensive network of seismic stations, GPS sensors, gas monitoring systems, thermal cameras, and satellite observations continuously tracks every movement of the volcano. Researchers are also deploying advanced robotic systems capable of measuring volcanic gases in hazardous terrain, helping scientists better understand changes occurring beneath the surface. For now, Mount Etna remains active but closely monitored. The renewed ash emissions of June 2026 are another reminder that the giant Sicilian volcano is far from dormant. While the chances of a catastrophic flank collapse remain uncertain and likely represent a long-term geological hazard rather than an immediate threat, researchers agree on one point. Understanding how Etna's massive structure evolves may be crucial for anticipating future volcanic and tsunami risks. As ash continues to rise above Sicily's skyline, scientists will be watching every tremor, every gas plume, and every millimeter of movement, searching for clues about what Europe's most active volcano might do next. What makes Mount Etna particularly challenging for scientists is the sheer size and complexity of the volcanic system. Rising more than 3,300 meters above Sicily, the volcano contains multiple summit craters, hundreds of flank vents, and a vast network of underground magma pathways that are constantly evolving. Even relatively small changes in pressure beneath the mountain can alter eruption patterns, trigger localized earthquakes, or accelerate ground deformation across portions of the volcano. Researchers say understanding these interconnected processes remains one of the greatest challenges in modern volcanology. Recent eruptive activity during 2026 has reinforced concerns that magma continues to migrate through the system, maintaining pressure beneath parts of the volcano's eastern flank. A worst-case collapse scenario, while considered highly unlikely in the near future, remains the subject of intense scientific study. If a large section of Etna's unstable southeastern flank were to fail suddenly, millions of cubic meters of rock could plunge into the Ionian Sea. Such an event could potentially generate dangerous tsunami waves capable of affecting coastlines across Sicily and parts of the eastern Mediterranean. Geological evidence suggests that similar large-scale collapses may have occurred in Etna's distant past, leaving behind massive scars in the volcanic landscape that are still visible today. For communities living around the volcano, however, the more immediate concern remains ashfall and eruptive activity. Even moderate eruptions can disrupt air traffic, damage crops, contaminate water supplies, and create hazardous conditions on roads.